Hi, I'm Mary Manohar from Nutanix. I'll be talking about policy-based routing in OVN. My colleague Shraddha Datta and I worked on this project together. Unfortunately, she couldn't be here for the conference. Here is the outline of the talk. We'll start with what is policy-based routing. Then I'll get into the implementation details in OVN, how service chaining works with our implementation, and some of the enhancements we'd like to follow upon. So what is policy-based routing? Traditionally, IP routing is based on the destination field of the IP header. Policy-based routing gives us an ability to create a policy for packets and filter packets based on certain fields in the IP header, like the IP source and destination, the IP protocol type, L4 fields like source port, destination port, and even the incoming interface on the router. So every policy has a priority attached to it. So if a packet matches multiple policies, the policy with the highest priority wins. Why do we need policy-based routing? Policy-based routing is useful for doing service insertions on the router. So we could reroute certain types of traffic, filter traffic based on certain parameters, and send them to services like firewall or VPN. The thing to note here is policy-based routing is not intended to replace IP routing. It is a way to override routing decisions as and when we need. In addition to reroute rules, it's also possible to do permit deny rules on the router. I have an example network here. There's a single logical router right on top. There are two logical switches, subnet 1 and subnet 2. Subnet 1 has VM1 and VM2. Subnet 2 has VM3 and VM4. There's a third logical switch called firewall that's hosting a firewall VM. When VM1 wants to send a packet to VM2, the packet goes to subnet 1, then it goes to the logical router. At the logical router, the lookup is based on the destination IP, which is VM4's VM's IP. The packet goes to subnet 2, and at subnet 2, it gets forwarded to VM4. This is traditional destination-based routing. In the case of policy-based routing, it is possible to add a policy to classify a packet as follows. If you look at the policy at the bottom, it has a priority 10. The source IP is subnet 1, that is the IP prefix attached to the logical switch of subnet 1. Destination IP is subnet 2, and the reroute IP is the firewall VM's IP. So in this case, the packet from VM1 goes to the logical router. At the logical router, it hits the policy, and the packet gets forwarded to the firewall VM. Now, what happens when the packet comes back from the firewall VM? It hits the policy again. The packet keeps moving back and forth between the logical router and the firewall VM. To prevent that looping of packet, we've added an additional policy with a higher priority, policy with priority 20, that says that when the packet comes from the from the firewall interface, the incoming interface is the firewall interface, and the remaining match criteria remain the same, that is source IP is subnet 1, destination IP is subnet 2. The action is permit. By saying the action is permit, we are indicating to the router that the policy does not have an input for the forwarding decision, and the IP routing decision needs to be honored. So now let's look at the implementation in OVN. Here are the list of tables in the Ingress pipeline of the logical router in OVN. We have the L2 admission control, then IP input, a couple of tables, NSNAT and DNAT to translate public IPs to private IPs for packets coming in from the external world, followed by IP routing and ARP resolution. The proposed solution is to insert a table between the IP routing table and the ARP resolution table. By adding a table after the IP routing table, it's possible to override the routing decision. So we let the IP routing table contain all the destination-based routes, And with the policy-based routing table can go and override those routes as and when needed. The table needs to be before the ARP table because the next hop IP needs to be resolved. The good thing about the location of this table and also the IP routing table is at these stages, this pipeline stage 5, 6, and 7, we are only dealing with private IPs. The packets coming in from the external world are already, the public IPs are translated to private IPs in IT3 and IT4, UNSNAT and DNAT, and the translation from private IPs to public IPs for outgoing packets happens in the egress pipeline. So in the policy-based routing stage, we can focus only on private IPs, and the policies can all work on private IPs. As I mentioned earlier, policy-based routing overrides routing decisions based on the policies, and IP routing table continues to exist. In the example that we saw, traffic to the firewall was forwarded based on policies, but the return traffic from the firewall was based on the IP routing table. So the IP routing table continues to exist. Here are the OVN NB commands proposed. The command to add a policy is LR policy add. And the parameters are router, priority, match string, and an action, and an optional parameter of next hop. The action can be permit, deny, or reroute. A policy is uniquely identified by a priority and a match string, so it is possible to have multiple policies with the same priority. In the example I've given, I have 2 policies with priority 10 with different match strings. The expression for the match string is similar to the match string in the logical flow of the OVN southbound database. The command to delete a policy is LR policy delete. Del, it takes router as a parameter, and priority and match are optional fields. If the user gives the router, priority, and match, the exact policy is deleted. If just the router and priority are provided, all the policies for the given priority are deleted. And if the router alone is provided, all the policies under the router are deleted. The command to list the policies is LR policy list, and it takes router as a parameter. Here is the sample output of the command, command. The new pipeline stage does not decrement TTL, because TTL is already decremented in the IP routing stage. We don't need to worry about decrementing it again. Let's see how this implementation works for service chaining. Here I have a logical router and subnet 1 and subnet 2 again. There are 2 services now. There's a firewall service and a load balancer service, both on their respective logical switches. To achieve, for the packet to go from VM1 to VM4 via the firewall and the load balancer VM, I have 3 policies now. Let's walk through these policies. The lowest priority policy is priority 10, with the match string of source IP subnet 1, destination IP of subnet 2, reroute to firewall VM. That's the lowest priority policy. To override the policy, we have a policy to say that the incoming packet, the packets coming in from the firewall interface and matching this criteria have to get forwarded to the load balancer VM. And on top of that, we have another policy which says if the incoming interface is load balancer VM, the packet has to go to subnet 2. So this is how we achieve service chaining. Let's take a special case of L3 service insertion. In this example here, I have subnet 1 on the right side, which is a logical switch which is hosting the user VMs. And on the left side, there is an external switch which has a gateway router attached to it. I want to define a policy which says that any packet coming in from the external world needs to go through the firewall VM before it reaches subnet 1. Such a policy cannot be written based on the source IPs, because now source IP is all IPs that don't belong to any subnets attached to this logical router. So traffic coming in from the external world is any IPs that don't belong to any subnets attached to the logical router. So instead of using source IP as a qualifier here, I've used the incoming port as a qualifier. So the incoming port is external interface. If you look at the policy with priority 20, you see that the incoming interface is external interface here. So by defining the policies this way, it is possible to insert the firewall for traffic coming in from the external interface. Here is another case where I've extended service insertion for traffic coming in from the external world. But now I have two services, a firewall and an IDS. And I've made my policies more complicated now. So what I'm saying is all traffic to subnet 1, any traffic coming to subnet 1, that is, traffic could be coming in from the external world, or traffic could be coming in from some local subnets attached to the logical router. All traffic to subnet 1 goes through the firewall, but traffic coming from the external goes through both firewall and IDS. So just traffic coming from the external world gets additional level of protection and goes through two services. But all other traffic goes through only the firewall. To make that happen, how can I configure the policies? Of course, the first policy is straightforward, the policy with priority 10, where I'm saying source IP 0.0.0/0, and destination is subnet 1, reroute to firewall VM. That is, all traffic has to go to firewall VM. In the next policy, I need to define how I'm going to treat traffic coming in from the firewall interface. How am I going to distinguish the external traffic from the internal traffic when it comes in from the firewall interface? As we know, external IPs are all IPs that don't belong to any subnets attached to the logical router. So now I need a way of marking local subnets. So I can say that external is not of local subnets, right? So OVN already supports a construct called address sets, and address sets is a way of pooling multiple internal IPs into one set. The address set construct today takes only internal IP, only IP addresses. We would like to see it extended to include prefixes. So, or an address set like construct that could include a set of prefixes. So if we had a construct that could bring those multiple prefixes together, I could have written my policies this way to achieve the functionality that we talked about. So the lowest priority policy here would be source IP any, and destination subnet 1, reroute to the firewall VM. The next policy which says, defines how the traffic packet has to be handled when it comes from the firewall interface. So the policy with priority 20 says that when the traffic comes from firewall interface, it needs to go to the IDS VM, except if the source IP is coming from the address set. So if the traffic, if the IP address, the source IP belongs to the address set, then the traffic goes directly to subnet 1. It doesn't go through the IDS. So I'm going to talk about some of the enhancements that we would like to add to this functionality. The first one is logging, similar to logging that we have in OVN ACLs. The second thing is to make it possible for the policies to be stateful. Right now, the policies are stateless, so you need to have two policies to control bidirectional traffic. The third enhancement would be to have ECMP for next hop, so that we could spray traffic across multiple firewall VMs. I talked about address set enhancement already, where we want to bring in a bunch of prefixes into one address set and apply that in the PBR policy. The last one is, in addition to setting the next hop, it would also help to set fields in the packet like IP DSCP so that the gateway router can classify traffic based on it. Thank you.
Let's thank our speaker. We have plenty of time for questions, so I hope that some of you have some. Please come straight up to one of the mics.
Hey there.
Hey.
Great thing, by the way. This offers some solutions that I hadn't thought of for some problems that we have, so this is good. But one thing I was curious about, you mentioned that a possible enhancement for address sets would be to specify address prefixes.
Yeah.
Is that not something we have already? Because I'm kind of surprised by that, actually.
I haven't tried it.
Okay, because I thought you could give a masked address in an address set, and that you could essentially have a prefix that way. But
Right.
I was actually just checking the code right before I came up here just to try to find out, and I hadn't seen just yet. But it just sort of struck me as it seems like we should be able to do that already, but I'm not sure.
That's great then.
Yeah, I would say give it a try.
Okay, I'll do that.
Okay.
Thanks.
And if it's not in there, it's probably a fairly straightforward enhancement.
But
If prefixes for address sets isn't in there, it's probably a pretty straightforward enhancement.
okay, yeah, thanks.
We have time for more questions. Would anybody like to ask one?
Is there anything that you would actually need for logging? Since it looks like you're adding your own table, I would think that you could probably use, if you're adding that functionality, you probably can just do the same thing that we're doing for ACLs and do the logging. Is there something specific that you need for logging?
No, I just haven't tried it. I just haven't gotten around to trying it.
Okay. And then you were saying having being able to do something statefully. Are you able to use the existing contract to do that level of statefulness, or what?
Yeah,
what do you need?
Ideally we'd like to integrate it with contract. Again, I haven't tried it. Right now I'm just, my prototype was to just add stateless policies.
Okay. Great. Thanks.
Let's thank our speaker again.